Hi, let's discuss the solution of the given equation. Here what is the given equation? Sine inverse of 14 by mod x plus sine inverse of 2 root 15 by mod x equals to pi by 2. This is the given equation. Here our task is to calculate the values of x. For that we have to eliminate the sine inverse. Automatically we will get the required values of x. Solution. First let me write the given equation. Solution. Given equation is sine inverse of 14 by mod x plus sine inverse of 2 root 15 by mod x equals to pi by 2. This is the given equation. Here in both the terms there is a sine inverse, but on RHS there is a pi by 2. So what is the formula we have? See, already we have a one important formula in inverse trigonometric functions. What is that? Sine inverse of x plus cos inverse of x equals to pi by 2. Suppose if I transpose this second term to this side, I will get pi by 2 minus sine inverse of 2 root 15 by mod x, which can be written as cos inverse of 2 root 15 by mod x. That cos inverse x can be written as in terms of sine inverse. So in that step we will get a sine inverse on LHS as well as sine inverse on RHS. Then we can equate both the sides of theta. So automatically then we will get the required solution of x. So in the next step we will transpose the second term to that side. See, this implies sine inverse of 14 by mod x equals to pi by 2 minus sine inverse of 2 root 15 by mod x. Already we knew one formula, important result, means that is, let me write here, sine inverse of plus sine inverse of x plus cos inverse of x equals to pi by 2. Sine inverse of x plus cos inverse of x equals to pi by 2. This is very useful and important result in inverse trigonometric functions. So now in the next step, sine inverse of 14 by mod x, which is equals to pi by 2 minus sine inverse of x, means cos inverse of x. So it can be written as cos inverse of, what is x here? 2 root 15 by mod x. Cos inverse of 2 root 15 by mod x. In the next step, I want to write this cos inverse in terms of sine inverse. There is an important formula. Here I will write here sine inverse, not sine inverse, here we want cos inverse of x. Cos inverse of x equals to sine inverse of square root of 1 minus x square when x greater than 0. Automatically 2 root 15 by mod x means it is always greater than 0. In the next step we will apply that formula. This implies sine inverse of 14 by mod x, which is equals to sine inverse of square root of don't forget it, square root of 1 minus x square, 1 minus 2 root 15 by mod x whole square. This is what we got it. So on both the sides, means on LHS as well as on RHS there is a sine inverse, we can eliminate. Now in the next step, this implies 14 by mod x equals to 1 minus 2 root 15 by mod x whole square. The entire thing is under the root, but at the same time there is a constant. Here the square root of something, square root of, suppose if you take square root of x, when it is exist, when x greater than or equal to 0. So at the same time, and one more constant is there, that is 1 minus 2 root 15 by mod x whole square. See, keep in brackets the entire thing which is greater than or equal to 0. Now first we will take this one and then we will decide the constant, the values of x. Means in the next step, 1 minus 2 root 15 by mod x, right? 1 minus 2 root 15 by mod x. Here this whole square is there, whole square, keep in brackets, which should be greater than or equal to 0. In the next step, this implies, see, take LCM as a mod x minus 2 root 15 whole square. 2 root 15 means, let me write that direct step. instead of writing every time, see, this can be written as 1 minus 2 root 15 whole square. 4 into 15 means 60. See, this is 60 by mod x whole square. Should be greater than or equal to 0. Keep it within the brackets. See, in the next step, take mod x square as an LCM. So, it can be written as mod x square minus 60 by mod x square should be greater than or equal to 0. So, this implies mod x square minus 60 should be greater than or equal to 0. This implies mod x square greater than or equal to 60. This implies mod x greater than or equal to square root of 60. Square root of 60 means you can write 50 into 4. So, finally we can write square root of 4 means 2 into root 15. So, this is what the constant of mod x. At the same time you can write x greater than or equal to plus or minus 2 root 15. So, this is the set of values of x which should satisfy this these are the values only can satisfy the given equation. Why? There is a reason. See, there is a square root of 1 minus 2 root 15 by mod x whole square. So, when it is exists, when mod x greater than or equal to 2 root 15. So, we decide the constants of x, the values of x, and then we will go see further. Okay, in the next step we will solve the x values. So, we will here the next step we will solve. We will solve the mod x. See, keep in mind at the same time I am writing here. See, 2 root 15 mod x should be greater than or equal to 2 root 15. So, in the next step you take 14 by mod x. 14 by mod x equals to square root of 1 minus 2 root 15 by mod x whole square. So, in the next step which is equals to, see, 14 by mod x, or you can take squaring on both sides, you will get a 14 square by mod x whole square which is equals to 1 minus 2 root 15 whole square means 4 into 15 60 by mod x square. So, this implies 196 by mod x square. See, there is a LCM mod x square minus 60 by mod x square, right? Mod x square gets cancelled. Finally, we are getting mod x 196 equals to mod x square minus 16. It can be written as mod x square equal to 256. This implies mod x equals to square root of 256 means 16. So, this implies x equal to plus or minus 16, which satisfies the given constant mod x greater than or equal to 2 root 15. So, therefore, the required solution for the given equation is x equals to plus or minus 16. So, at last, what is the concept we applied here? Simply, we applied two formulas. What is the first one? Sin inverse of x plus cos inverse of x equal to pi by 2. After applying this, we will get a sin inverse of x, something which is equals to cos inverse of x. From that, cos inverse of x, we have written in terms of sin inverse of x, that is cos inverse of x equals to sin inverse of square root of 1 minus x square. So, after equating both the sin inverse, means after eliminating the sin inverse, we will get some one equation in terms of mod x, and at the same time we got there is a constraint, means there is a square root of some x should be greater than or equal to 0. From that we decided the set of values of x, and finally we calculated the value of x, that is x equals to plus or minus 16. Thanks for watching. All the best.